Hello everyone. Well, this is a recording of chapter 4 of the network design course notes. And in this chapter, we're going to talk about network management activities. So the idea behind this chapter is that we discussed in the previous lectures network models. And if you go to the network models, you'll see that we touched on, or we talked about 5 functional areas: configuration management, fault management, performance, accounting, and security management, right? And these FCAPs together cover what what needs to be done to complete or to create a complete network management system. This These 5 came from the OSI framework. We talked about different four models, and one of them is the functional model. And from that, we have 5 functional areas. We also saw this in the TMN standard or framework, also talks about these FCAPs. So now we're going to talk about what is required in each one of these functional areas. And to cover this properly, um, you need to imagine that you are starting um, the process of creating a network management system from scratch, from nothing. So imagine yourself being hired as a network manager in a company that has a network working but not doesn't include or doesn't have any network management system. And this is how I usually start talking about this topic, like from a perspective of somebody who's starting from scratch, right? So imagine yourself doing that, and if you start um, day one trying to build a network management system, the first thing you will do, in my opinion, is to start thinking about configuration management. Right. So the configuration management is one of the 5 functional areas, and it's concerned about handling configuration of the network. But that's configuration is not just the configuration of the devices themselves, but include also documentation about the network, topology documentation, IP address documentation, VLAN documentation. It talks also about different um, standards. So, as you know, starting day one in this job, the first thing you need to do is to figure out what's in the network, what devices are in the network, and how they are connected to each other. All right, so that's the network discovery phase. And what you will do is really depends on the size of the network. If you have a small network, you probably will go to the room where the network devices are and just look at them and write them down. You may be tracing the cables to know how they're connected to each other, right? That's a manual process. You may go to each switch or each router, log in, and from the switch you can see which ports are on. You can look at the MAC table and see what are the nodes that are connected to each port and what their IP address is. So you can do this manually. You can go to the router and see what networks are directly connected to the router, and you write that manually. So that's the network discovery process. Well, that works for a small network, but how about a big network? well, then you probably need some tools. So you may need some network discovery tools that will do the same process that you did manually, just automated. So you may go and use this tool to um, log into devices, grab information from that device, and then you go from that device to the next one and so on. So you progress this way. And network discovery tools, sometimes they come as part of network management platform, a software, and they will do discovery from a starting point. We call it a seed, right? So you give them the seed, you give them the IP address and the access to one of the devices, and from that they will propagate and they will discover the rest of the network. So everything I would say today in this recording applies to networks of any size, right? Whether it's small, whether it's big, it doesn't matter. What's different is the tools. For a small network, you probably will just manually do the process and it will take you a couple of days. In a large network, probably you will use management tools or, I mean, this processes and automated tools to discover the network. You may also use your scripting skills and write the code yourself using Python or any other scripting language to discover the topology. So you may use any tools available to you. But that's step one. All right, so as part of this discovery process, you need to figure out the relationship between these devices. So how they are connected to each other. So that's the mapping. You need to have topology um, prepared, right? So the topology is important because you need to know the relationship between each these devices. All right, so after that, you may discover that you may need to create standards. So what are we talking about here? What kind of standards we talk about? So um, imagine some networks. If we see that we have a network that has routers connected to each other in this fashion or any other fashion. And these routers, as we always face in the lab, they have labels R1, R2, R3, right? And these labels, if we look at this kind of labels, we won't really get the sense of where these devices are, right? So this could be our naming convention in the lab where we call these routers R1, R2, R3. But imagine you are in a network, a production network, and you see these labels. They will not have an indication of where these devices are, right? So we may be needing a naming convention that will give us a clue about what these devices are or where they're located or their function. So I may change this to something like main gateway. So this label will indicate that this router is connected to the internet. This router, for example, may be given like building 1. So this will give me a clue about what the function of this router is. So why this is important? It's important because if I am looking at a map, I will know what these routers are located. If I am getting an alert in the middle of the night about a router being down, I will get an idea about what the router does and how important it is, right? So we'll call this naming convention, and this is one of the standards that you may need to create if it's not created already, right? So naming convention is a local standard for the company, and it's understood among your team and your team, and it will give a clue about the function of the device and its location, right? So this is one of the conventions that we need to create. Another type of standards that we could use in the network is IP standards, for example, and VLAN standards. So what I mean by that is, let's say you have several buildings in the network, or several departments, right? Building or department. So you may, for example, choose, instead of having IP addresses all over the place, you may choose to have a standard that says the third octet 192.168, and the third octet will represent a building. So 1 represents building 1, 2 represents building 2, and 3 represents building 3, and so on, right? So that convention will give you an idea. If you see an IP address coming from certain area, you know where it's coming from. You may also assign the same convention to a department. So 10 for accounting, 20 for engineering, 30 for manufacturing. And you can also assign that to a VLAN, right? So you have an association between a certain IP address and a certain VLAN. So VLAN 10 will have an IP address 10, and so on, right? So it doesn't matter what the convention is, as long as there is a convention that everybody understands, right? Everybody, by everybody I mean all the management team, right? Another type of standard is configuration standard, or configuration convention. So this, now, despite having different vendors, different manufacturing from different vendors, and each one of them have a different configuration, style or configuration commands, right? But we still can create a certain templates for specific devices. So let's say for a switch, I may create a template, as we looked in other courses. I may create a template that says it has a configuration presets, right? So the configuration template will disable all unused ports, will disable all unused protocols, will turn on SSH, will turn on the SNMP, will create or synchronize with the NTP server. All of these can be created in a template. It doesn't, because it's common to all switches, it's common to all devices in your network, so you don't really need to create this, or every time you have to configure a switch, you have to configure it from zero, right? So you can just upload the template, and then you change whatever you need to change in that particular switch or that particular router. So that will make things simplified for you, and also create a common configuration among all devices. Same thing, you may for interfaces, you may have the convention of creating a description for each interface, and that description will indicate what the port is for, right? Or what the interface is connected to. Topology documentation. Again, you can create a standard for the symbols that you use. This symbol is used for a switch, this symbol is used for a router. How do you present VLANs? How do you present tunnels, VPNs, etc.? Unfortunately, for our profession in networking, there is no common standard. Everybody draws topology the way they want, right? There is no, in other professions, you may have specific symbol for a specific device. You know what, if you are drawing electrical circuit, for example, you know what the symbol for capacitor, what the symbol for resistor, and all of that. In networking, there is no such thing, as far as I know. There are common conventions. When we see the shape of a router, like we understand it's a router, but that's convention. That's just not a common among all professionals. So for your team to eliminate any misunderstanding of the topology, you have to agree on a convention. Right? And I may show you in different demos what kind of conventions you may use for such drawing, as long as everybody understands the convention, well, you'll be okay. All right, so these are, if you look closely at the slide, you see that these are the initial activities. These are the things that you start with when you have nothing, right? You will begin with these activities. But then there is common activities that you do on a regular basis. So you see here in the common activities, there is network discovery. Why do I do network discovery again if I have done it once? Well, network discovery is needed on a regular basis because things change, right? You may plug in device, unplug device, and we saw in the security course that there's a lot of I mentioned also in this course that there's a lot of overlap between network management functions and network security functions. And I argue that you cannot have network security without network management. So part of the network security is to keep discovering or keep scanning the network to discover any rogue devices. So that's a common security practice. But also from the network management perspective, we need to know what devices we have at any point, not just for security reasons, but to discover the load, for example. If I have big wireless network, I need to discover, well, by the nature of the wireless, people come in, come out, right? So people join, the devices join the wireless network and leave. So I want to keep track of the changes. I want to also keep track of my inventory, my what's in the network, right? We did that in the network discovery. We probably created, depends on the size of the network, we may have created a big spreadsheet with all the devices and their IP address and vendors and probably other information like how long before we need to renew the license or how long before the support, technical support from the vendor is over. So we need to build that database. If we have a small network, we may create it in a small piece of paper. If we have a large network, we may need a database, a relational database to create all of this. So it depends. Another factor we need to, or another very important job in the network configuration or configuration management function is to back up the configurations. Right? So I don't know if there is no slide for it here, but why do we need to back up the configuration? Well, things happen. Device may fail. A device may be subject to misconfiguration by mistake, right? Having a configuration backup means that we can recover from that mistake quickly. A device failed, I may go and buy another hardware, right? But how about the configuration? If I'm going to configure everything from scratch, well, do I have enough documentation? Can we replace everything from memory? Well, it's much easier to use configuration backup, right? We can also subject that configuration backup to version control. So you can use Git, for example, to maintain versions of the configuration. So if somebody changes something, and then you can go back and recover, okay, so this didn't work, let's go to the previous version and restore everything. So you can use version control to manage the backups. Backups are important, so they need to be secure as well. Then we have the network audit as part of change management, as part of configuration management. So why do we need audit? Audit doesn't happen every day, it doesn't happen every week, but it may need it for every 6 months, every year, every 2 years, depends on the circumstances. So the benefit of the audit is to make sure that anything that changed is captured. So if I make a change and then it's not documented for some reason, right? So I catch it during the audit. So if if I built the topology of the network and discovered all devices, built everything, draw everything, but then something happened and changed and I forgot, or the team forgot to update the documentation. Well, that can be caught during the audit. So the audit involves the same steps as the initial activities. It will include network discovery, network mapping, maybe not creating the standards, but doing some of these initial activities from scratch, from the beginning. Why? Well, as I said, to discover any configuration change, any topology change that I didn't catch or I didn't document. Also, audit can be important for compliance and for security compliance. There are a lot of standards and regulations that require the organization, the company, to provide proof that they are adhering to the standards or regulations. And that comes by providing an audit. So the audit will look at the network and generate a report and say, well, here's what we are doing. This is what we have. This is what we did. So an audit will be part of that process. Audit can be done automatically or can be done manually. It depends on the size of the network. It depends on also other factors. So if you want to do it every 2 months, then probably the process should be automated as much as possible because, well, it's frequent enough. If you're doing it every 2 years, then probably you don't need to automate it, or you will spend time doing the process manually. Automating it or spending time trying to automate something that you do every 2 weeks, it's probably every 2 years, it's probably not an efficient use of the resources. Okay, you notice here that I skipped something, which is change management. Let's go back. Change management. Change control, right? So change control is one of those things that we will focus on at the end of this recording in more detail. But the idea behind change control is once you spend all the time discovering the network, mapping it, documenting the topology, saving the configuration, and you do all of this, right? You don't want to, yes, we talked about audit, right? Every year, every 2 years, but you don't want to make a mess until you catch it in the audit. You want to make sure that any change happens in the network, it's following a specific procedure. Not just because we lose documentation. No, it's the impact is more than that. So let's say somebody changed a VLAN in the middle of the day, and in the cause of changing the VLAN, it disrupts the function of the network and people will lose connectivity. Employees will lose connectivity. Somebody tried to change something in the routing protocol, and as a result, things stop working. This is the kind of things that happen, believe me, all the time, right, in networks that are not managed properly. And the reason behind that is there is no formal procedure for change control. People will go and, oh, I changed something, let's reboot the switch. Well, rebooting the switch will disrupt the connection for devices at least for the time for a few minutes, if not more, if let's say you made a configuration change and you didn't save it, right? So the change control is all the process that, or the formal mechanism that uh, allow the team to correctly make a change in and notify people of the change and try to make this change with the least amount of disruption to the business. So, as a common way to make a change is to allocate certain time of the week on certain hours where we can say, well, Friday 4 to 6 in the morning, right? Nobody, there will be a change. That's every week. There will be a change in the network, so nobody does anything important during that time. That time is dedicated to making changes to the network, right? Some organizations do that. Other organizations follow another process. So because the change is not often, so they won't do this on a regular basis, but every time they want to do it, they announce, well, during the weekend, we will be making a change in the network from 7 to 10 in the morning, so expect maybe disruption to connections. So people, the employees will pay attention to this and they will not be surprised by having or lacking of or lack of connectivity. So the process itself is part of configuration management, but it is uh, important enough that we will talk about it separately at the end of this recording. Right. Um, so if you look back at all of these activities, this is just part of one functional area, which is the configuration management. And you see that it's a very important area, right? And as somebody who started doing network management, this is probably where you should start. Now, what comes next? So now you have all the network being documented and configuration saved and convention created. Change management probably you will do it at some point, maybe not early, but at some point in the future. What's next? So what's next comes the fault management. So fault management is the part of the or one of the functional areas that's concerned about mainly about detecting faults, right? So this is like either working or not working situation, right? So we're not talking about uh, near near failure. We're talking about failure. So in fault management, um, we need to use the protocols and the tools that we learned in previous chapters in order to detect whether a device is working or not, or a service is working or not. So what kind of tools we had in the past? We looked at syslog that sends messages, and some of these messages will carry severity level. So we saw that we may get an error, or we may get a notification, or we may get an emergency. So these are indications that there's something wrong. Right? We saw traps, SNMP traps. So SMP protocol can be configured so a device will send a trap to indicate a fault. A port went down or a power supply of the switch went down, so it sends a trap to the network management system. So now it indicates a fault. We will call these techniques passive fault detection. Why? Because the network management system sits and waits for these events to happen, waits for them to come, right? Um, which is good, except that there is a condition to that. The device itself has to be active in order to send a syslog or send SNMP trap. It cannot, a, a printer that's down is not going to send a trap. Uh, a camera that's down is not going to send a syslog message, or a switch that's down is not going to send any notifications. So that by itself is not enough. We need active fault detection. So active fault detections is where the network management system sends polling requests to the devices, usually using ping, for example. You can ping the devices every 5 minutes, every 10 minutes. If the ping comes back, that's great, the device is still active. If doesn't come back, we know that there is a problem. Okay, so um, we need the two of them. We need the passive and active fault detection. The active fault detection is not just by ping. We can also, if I send an SNMP request and the request doesn't come back, also that's active. If I try to open port 80 on a server and we don't get a reply, well, we know that port 80 or that service is not active. So there are many techniques. So, but generally, we will have both passive and active. Also, I may also say that with active fault detection, we may not know the details. We may, well, when we ping a router, we don't really know if, well, we know that the router replied, right, or not. But let's say the router is busy. We don't know if the router is busy or not because ping does not give us this indication. We don't know if the routing protocol is working or not because the ping does not give us that notification. So we may need both passive and active to get the full picture. Okay, so when we talk about fault detection, ping of certain type of polling or all of this, so that you notice that I mentioned network management system. So that's the piece of software or the platform that does all this process, automatically every 5 minutes, every 10 minutes. But that by itself is not going to tell the administrator that there is a problem, right? So the next step in the life cycle of fault management is event or alarm generation. So that takes different shapes. The network management system, when ICMP ping does not come back, it may send us an email saying, well, I tried to ping this device and it's not coming back, right? Or it may be SMS message. Right? It may also, if imagine you have a network operation center and you have all of these devices surrounding you, all these screens, you need to pay attention to a problem by probably having a sound, an alarm or a siren that goes off to tell you there is a problem. You may also have a visual alert by something flashes red in front of you on the screen. So all of these are um, ways to get the administrator's attention. We can also send an syslog message to another device. So this may be one network management system alerting another network management system. So we may get different ways or may have different ways to send an alarm to get the attention of the administrator. The next step in the life cycle is fault isolation. So we may have a lot of automated techniques to recover from faults. Right? So for example, if we have two routers working in a redundancy using VRRP, for example, one fails, the other one takes over automatically, right? Because of the nature of the protocol, it detects or provides a mechanism of detecting the error. But generally speaking, there are a lot of things that require the administrators, the people, attention. So if you get a message sometime in the evening after you leave work and that says router gateway or the main gateway is down, so that's where you start thinking, okay, so what is the problem? Why is it down? Is it down because of overload? Is it down because the connection to the internet is down? Is it down because of power supply failure, because of congestion? All right, so that's where your work in the configuration management part pays off. If you have good name and convention, you will figure out quickly where the device is and where it's located. If you have good network mapping, you will know where the device is located in the network and how significant it is, right? If you have configured syslog, you will be able to go to the syslog messages and see the sequence of events that happened before the failure, right? Same thing if you have SNMP data, you may see that the CPU level went up until it became too high, so now the router fails or crashed because of overload. So all of this requires um, good planning, requires knowledge of networking technologies, require knowledge of the network itself, right? So it plays all of this plays into detecting or isolating the fault. Isolating the fault means that not just isolating or recognizing where the problem happened exactly, but also why it happened. If I don't know why, I'm not going to be able um, to um, to recover from it, right? So speaking of recovery, so now the last step in the life cycle is the correction. So now I know what the problem was. What can I do about it? Well, it depends on the problem, of course. If the problem was a security breach, denial of service attack, I may go and block certain networks to prevent that from continuing. If it's a hardware failure, if it's a power supply that went down, I may go and replace the switch with another switch. Hopefully, I did, or I have a backup somewhere in the storage. Uh, it may be just a temporary thing, maybe overload, an unexpected traffic in the network. So maybe I just wait it out and everything will go back to normal, or we will do a restart. So here, where the possibilities are endless, and there is no, you may have um, troubleshooting techniques or troubleshooting procedures that you follow to make this faster, but really depends on the experience and it depends on the topology and depends on what you did in the past. If you have a network management system, you will be able to figure this out very quickly. If you don't, then you will need to do this the hard way, right? But of course, while you are doing the process of building a network management system, that will become easier and easier as you go. Another part of fault management, this is probably involving people rather than automated process. So this is the ticket management system. Right? So in ticket management systems, you are relying on users to tell you about problems. So ticket management system could be as simple as an email, support at company.com, for example, where any user, employee in the company or a customer who experience problem with the network can send you an email saying, here's the issue that I'm having. You receive that email and you respond to it. Uh, this could be more sophisticated software as well. We call it trouble ticket system, where you may provide a web interface, somebody logs in, describe the problem, um, and send it to you. On the other side, um, trouble ticket system or ticket management system can take this information or these tickets and classify them based on, let's say, buildings. So problem come from building 1, it's assigned to that person. Problem coming from building 2 is assigned to that person, and that's useful if you have a large company with a lot of branches, right? It could be classified based on the type of trouble itself. Somebody has experience with the internet, you forward it to somebody else. Somebody has experience maybe with certain servers, you will send the trouble to people who are responsible for applications and so on. Some ticket management system may offer uh, tips to the user, so it relieves some load on the people who are providing support. So the user comes and say, well, I have a problem with this. So the ticket management system suggests, did you try this? Did you try this? Did you try this? Or provides Q&A page where the user may go and check the problem first. Maybe somebody else experienced the same thing and they have a solution, so they will implement the solution. So that relieves some of the tasks from uh, relieves you from the dealings with some of these tasks themselves yourself. Okay, um, so fault management deals with something that it's either working or not working, as I said. Performance management deals with the issues that are in between, right? So when we talk about performance management, we are talking about everyday process, everyday situation. The network is healthy, the network is not healthy. So what they mean by network is healthy? Well, if you compare that to a car, well, if everything, the fuel is good, the temperature is good, the rotation per minute of the engine is good, well, the car is working normally. But if you are noticing that the fuel is close to um, empty, then you know that if you continue driving, you will be at some point you will run out of fuel. If you know that the temperature of the engine, you see the gauge is going very high, you know that you may cause damage to the engine if you continue. So these are, when we look at the network, these are the performance issues that we need to think about. So if you look at, let's say, traffic across certain link, And we know that the maximum bandwidth is 100 megabits per second, right? And if you see that the network is consuming bandwidth at this level, you will see that, okay, you have plenty of bandwidth left. Yeah. If you see the bandwidth is going up that high, you know that you are close to being uh, exhausting the bandwidth on this link. Right? So you will see that to be able to look at this and monitor the performance of the network, we need to, first of all, we need to collect historical information. We cannot just look at instance and say, well, the network is good or bad. It may not be enough. Maybe in some cases, but it may not be enough. Right? So we may need to collect historical information and keep track of the data over a certain period of time to know if the network is working fine or not. In some cases, well, if you see the fuel gauge is all zero, you don't need the history. You know that you are in trouble. But in other cases, well, you will see or you will need to uh, know the history. So we will call that the baseline. So knowing what the normal situation is the first step in establishing or in performance management. You need to know what is the normal behavior of the network to be able to find out if the network is behaving normally or not. You need to know what the normal behavior is. So this means that you need to collect data over a certain period of time. The period of time could be 1 day or it could be 1 week. It depends on the activities of the network. So let's say I'm looking at the bandwidth going to the internet. So I see that the traffic is normally going up and down, where normally the traffic starts slow at 8 a.m. and goes high around 12 and then goes low again around 4 and it repeats this way. Right? So this can be your normal behavior. If you look at the main router, for example, and you look at the CPU level, so this is the 100% CPU level or utilization. If you see that the traffic is going, the CPU is normally around 5, right? So that's your normal behavior. Right? Now, once I know the normal behavior of my network, I can, let's say someday a traffic goes like this, or the CPU shoots up like this and becomes close to 100. That gives me an indication that there is something is wrong, or something maybe not wrong in the sense that there is something bad happening, but it's just something that's not usual, right? Maybe it could be something as simple as, well, the company has the general meeting of the board on that day, and there's a lot of activities in the network, so that's why you have high traffic. Or maybe there's you're launching a new product, so the traffic is going higher than usual, right? So um, it may be not benign thing, not really something bad, but it could be also an indication of something bad happening. Somebody is leaking a huge amount of information to the outside or denial of service attack. So that's another overlap between network management and network security. Right? So in order to detect these things, well, if you're looking at the graphs, you will be able to see that. But not always you expect that people will be looking at graphs and diagrams, we may be not looking at that. So how can the system detects these anomalies? So one way we can do that is to build thresholds. So I can say that here is a threshold. If the network utilization or bandwidth utilization exceeds 90% or 90 megabits per second in this case, send an alert. So as long as the traffic is below 90 megabits per second, everything is fine. If it exceeds, then you will get an alert. Same thing here, I may say, well, normal CPU load is 5%, but if the load exceeds 50% utilization, then I want to get an alert. The threshold can be upper threshold or can be lower. You can have a threshold at the bottom here and say, well, if the traffic is below 10 megabits per second, send me an alert. Why is that? Well, normally you could say the normal behavior is I have 20 megabits per second or higher in the link. But if I have less than that, there may be some failures that I didn't detect otherwise, right? I may have the people who are or servers who are normally sending traffic or receiving traffic, they're not sending or receiving. So maybe there's something going on other parts of the network that makes this traffic drops below normal level. Right? So that's what we mean by setting thresholds. Right? Another part of performance management is visualization and reporting. So visualizations, as we saw in this example, they are very good indications the I of the status of the network. I can see a map, and if I see all the nodes in the map green, well, I know that everything is good, right? If I see something that's red or yellow, it means that there's a warning or a fault. So visualization is a very good way to provide quick indication to the human, to the administrator about the health of the network. Right? Another another way to or another benefit of visualization is to recognize trends. So in the example that I showed you, you may see that the daily traffic is going this way, up and down, up and down. But if I measure traffic over a long period of time, over a year, for example, and get the summary every week of the year, so we have 52 weeks, or every month, so we have 12 periods, I may see that things are slowly, bandwidth, for example, slowly going up, right? So locally, it may be going up and down, but then in the general trend, it's going up, right? So if I am setting a threshold here, well, I may not get uh, an alert until late, right? But if I see the trend here, I'll say, okay, the network consumption or the bandwidth consumption in the company is going up and up and up continuously. That may not be because of any problem, but because people are using the network more often. Maybe we have more employees in the company. Maybe we have more services offered over the network. Maybe we are putting a lot of things in the cloud, so the use of the internet is increasing. So the trend is going up. So maybe before I get to that point, maybe here I'll decide that I need to upgrade my internet connection. Maybe I'll buy more bandwidth, or I have another connection to another service provider, right? To balance the traffic between two links. So maybe I'll take an action before I get to the point here. Same thing if I see a CPU load going slowly up, or the memory, free memory going continuously down, I know that, okay, so maybe the router is getting busier and busier and busier, and there is a lot of, you know, routes being used by or saved by the router, and the memory consumption is getting higher, and the free memory getting low. So at some point I need to decide that I need to upgrade my router. So all of this will give you the trends, what we talk about, the trends here, uh, give you historical perspective, right? And gives you a way to see what's coming. If you take those graphs on those trends and use them to ask for money, it will be an evidence, right? If you go to your boss and say, well, I need to buy more bandwidth, say, okay, why? Well, here we have a graph that shows a continuous trend upward, so we need to have more bandwidth at some point, or we need to upgrade our switch at some point, right? So that will give you, that's the reporting is important part of performance management. Okay, so we covered so far 3 functional areas out of 5. The next functional area is security management, and this is really should be seen as part of information security in general. And it is specifically dedicated to securing the network and securing its use as well, right? So if you follow what I said, you start from day one, did the configuration management, did fault management, did performance management. Should I do security management fourth? Is that wise? Well, here you may actually try to do the security management earlier, um, as part of, or at the same time as configuration management. Oh, well, I'll let you decide what is the appropriate time to configure or to do or implement the security management function in your network. But in general, we need to do these tasks. So the tasks are, well, first of all, restrict device access. Secure the device access by username and password, or by authentication server, by any of the techniques that you know in security. We talked about also accountability in the security. So how do you achieve accountability? By maintaining logs. So the logs are also something that overlaps between network management and network security. So anytime somebody accesses a device and change a configuration, we need to keep a log. The log will be to go back if something happens, if a fault happens, as I said earlier, we can go to the logs and see what kind of changes happened. And maybe somebody disabled an interface or changed the configuration, the routing configuration. So that will give us indication of what happened. From the security perspective, we know that if there is any malicious action happened, we need to generate alarms related to security. So somebody logs, or if you have multiple log failures, maybe this is something that trying to access the device without an authorization, trying to guess a password, for example. So all of this is common approaches that we know from the security knowledge that we have. Then we also can have general policies that help secure the network. And these are overlapping also with the security policies in general. For example, I may say um, all passwords that are needed has to be in a certain length and they have to be changed um, regularly every 6 months, for example. The acceptable use policies. Don't use this network except for work purposes. Don't use it for games. Don't use it for to access illegal sites and so on, right? Um, in terms of network management teams, not everybody has to access everything. Okay, so some senior staff may be able to configure the devices while the junior staff may be able only to log in and look at the configuration but not change anything. So you manage the access policies. If you have users who are logging in from the outside, remote users, so you may say, well, the access policy say you cannot use your own devices to access the network. You have to use devices that are supplied by the company, or you have to use this particular software. So you may have all of these. You will see here there is a lot of overlap between the security management function and general security practices. Our last functional area is accounting management. So this is responsible for measuring resources being used in the network for the purpose of charging, right? Um, so that may not be relevant to all organizations. But if you are a service provider, if you are an internet service provider, then your customers are charged by how much bandwidth they use. So you need to implement accounting management in order to monitor how much the customer is using and then charge them based on their use. So there is a link between accounting management and the accounting software, the financial accounting software, right? So uh, you may be able to link the two. If you are a data center, a cloud service provider, and you are charging the users by the amount of bandwidth that they consume. They do that as well. So doing, you will be needing accounting management. Some organizations use accounting management not to physically or not to literally charge customers, but they just want to monitor how much resources they use, right? So that's accounting management in general is dedicated to measuring the amount of resources, and by resources could be how much bandwidth they're using, how many ports they're accessing, things like that. And they may do it internally just so that they can monitor which department uses what resources, right? So they can allocate resources based on that, or they can uh, measure uh, how much um, cost this product, or what is the production of this product costing us, things like that. So if you look back at all these functional areas, you'll see that we started from the beginning. The most basic is managing the configuration, and having the documentation in general, and then we went to detecting faults, whether it's something working, something not working. And this is important because the main function of a network management or network manager is to make sure that the network is working, right? Then we have the management, which gives us an idea about the health of the network and where it's going. It allows us to predict. Then we have security management, which probably shouldn't be in the fourth category or the fourth step, but somewhere along the road has to be implemented. And then accounting management, which monitors the resources. Right? So now that you have done all the work, you may discover that, well, there is a lot to network management, and the team cannot handle all these tasks. So you need to think about outsourcing, right? And organizations think about outsourcing for many reasons. Outsourcing is basically giving or assigning certain management or planning or implementation or operation tasks to somebody else, to another company or a contractor. A person could be a person or a company. So that does this job on your behalf, right? So you pay them to do this. You pay them either by once by the task, or you pay them regularly, right? So examples, if I want to uh, add three more switches to the network and I don't have time to configure them myself, I may go and hire somebody to configure these devices. So this is because I don't have time. Uh, Maybe I don't have the expertise to create a network management policy or security policy. So I may go and hire somebody to look at my firewalls and give me advice on what kind of policies I need to add or or improve. Right. So you will see that there are a lot of reasons for that. Some actually organizations hand the task of network management entirely to another organization. So they say, well, we'll just you are the ones who uh, manage the network, get the alert, get the notifications, uh, look at the performance, do all of these tasks. You just give us a report every month, right? Or or even if you want to do upgrade, you go ahead and do upgrades yourself. We just pay you a fixed amount of money every month to do these tasks. So motivations for outsourcing vary. Sometimes it's cheaper to hand over network management to somebody else rather than hiring a person to do this, right? So a company may be able to do lots of network management for others, right? But at a lower price than hiring a dedicated person. Um, the IT staff may be more responsible for applications and servers, and networking is not their expertise, so they may hand over the task of managing the network to somebody else, right? Uh, some organizations would contract a service provider to say, well, you deal with the network, you decide when you need to upgrade and when you need to use newer technology. We just need a network to be working, right? So this may be a better way to maintain that the network is always up to date in terms of state of the art technology. If I'm doing it myself, I may need to uh, pay capital for every 5 months to upgrade the entire network. But if I hand it to somebody else, they may do it in a different and efficient way. So really, that's you have here 6 different reasons for doing outsourcing, and maybe there are more, but sometimes the company just say, well, in order to not being sued, if somebody sue us for uh, security breach, we may say, well, we handed over all of the security tasks to another company, so you go sue them, right? Instead of us. Um, so that's a mitigating risk. And maybe the risk would be less if I'm handing over the security to a dedicated company for security that have the expertise rather than doing it myself, right? So you will see here that these are what you are handing over is one of those functional areas. It may be the security, it may be the configuration, it may be the performance, it may be all of them. Right? So when you outsource, the task, you need to have a contract. So a common thing in in the network field or in networking is the service level agreement. You probably heard of service level agreement multiple times, and these are the contracts or the technical part of the contract that specifies what are the expectations between the customer and the service provider. What are the services and what are the expectations? Sometimes it goes into details like the delay, for example, or the reliability, or um, uh, specifics, bandwidth, for example. Um, it depends on the service. So you may be at either end of the service agreement. You may be the customer. So if you hand over um, the configuration of your network to somebody else, then you are the customer and the others are the service provider. Or you may be the one who is providing service. So if you are the one who's managing the network for others, then you are the service provider and the others are the customer. So either way, it's very important that we know about service level agreements. So what's the content? So in one of the appendices in your notes, you will find a template or you'll find a typical service level agreement. Here we're covering just the main clauses. So the first thing is the description of the service. It could be, well, as an example, I'll take two examples. So one example, I'll assume that you are the customer and you have a network here and you are connecting to an ISP. So here's the customer and the service provider is the internet service provider. In another situation, you are the contractor who are providing support, tech support. So somebody calls you when organization have a problem in the network, they call you to provide support, troubleshoot the network and figure out what's wrong with it, right? So in the first case, well, the description of the service will be we provide an internet connectivity to you at this rate with this amount of money, right? So the rate will be, or the bandwidth will be 800 megabits per second, and the cost will be X amount of dollars. In this case, you will say, well, I can provide technical support to troubleshoot and um, restore a network activity, right, at the cost of maybe certain amounts per hour. Okay, so the next clause will be the reliability. So the reliability here will be different in each case. So in the case of the ISP, the reliability refers to reliability of the service. And usually it's expressed in terms of percentage. So the reliability will be maybe 99.5%, which means that this link here, usually the reliability is measured monthly. So this link here has to be available for at least certain hours per month. We may tolerate certain outage that doesn't exceed this level, right? So this will give the customer an indication of the amount or the percentage of time that the network will be available. If we don't have this, well, then there is no guarantee that we may have a bandwidth, 100 megabits per second bandwidth, but only 1 hour a day. Is that acceptable? Of course not, right? But from the service provider will say, yes, you asked us for a link and we provided you a link with 100 megabits per second bandwidth, but we don't have a guarantee. We didn't say that you will have it 8 hours a day or 19 hours a day. We didn't say that. Now, um, so, well, that's an exaggeration, but it guarantees certain level of availability to the customer, right? Uh, and what the guarantee means? The guarantee means that if this level of service is not provided, then it could be there is a penalty uh, cost to the service provider. So usually we'll go to another clause here, which is the consequences for not meeting service obligations. So what happens if the service provider cannot maintain 99.5% availability? Well, they could pay back some of the money. So if you are paying them X amount of money per month, and in 1 month they cannot achieve 99.5, so they may pay you back amount of money proportional to how much they are behind. So if they get only to 99.3, so they may give you 10% back. If they go below 99%, they will give you 15% back, and so on to the point where they give you all the money back if they maybe achieve only 50%. Right? The reliability in terms of service contracts, like the one to the right here, may be different, expressed differently. So it may be referring to the quality of work rather than a percentage of availability, right? So it may not be exactly the same, but the consequences could be also the same. If you don't deliver on time, there may be some consequence. Responsiveness here refers not to the delay of the network, not like remember the service level agreement does not always refer to uh, internet connection. It may refer to another type of contract. But so the responsiveness here refers to the punctuality of the services. Okay, so what I mean by that, let's say, and as a contractor, um, I get, or as a customer of a contractor, I have a problem in the network and I call the contractor to come and provide me with the tech support, and they don't answer my call. Well, obviously, that's not responsive, right? So I may leave a message and they may not call me back until maybe 6 hours later. Well, and then they come back and say, well, we didn't really say we should call or we should call back right away. So the responsiveness clause tells or sets the expectation of when the service provider should respond to your inquiry or to your request. So that should save both sides. So let's say you're calling as a customer, you're calling the contractor in the middle of the night at 12 o'clock. Should you expect that she calls you back immediately? Maybe not. So the contract says, well, the response should be within 2 hours during business hours, and maybe within 8 hours during evenings and weekends. So this means that if you call somebody in the middle of the night, well, they can call you back maybe at 7 o'clock in the morning, right, within 8 hours instead of just dropping everything. So that protects both sides and also sets the expectations. The customer knows that they are we they can expect the service to happen within certain amount of time. Same thing if the ISP connection fails and I call the tech support, they may say, well, we can respond to you within 2 hours, for example. So that will set certain expectations uh, for the response. So that's what we mean by the responsiveness. Procedure for reporting problems. Again, this is important. Should I call the contractor in the middle of the night while they're sleeping? Um, or should I send them an email instead? So again, this is where a trouble ticket system may be working. So you may say, well, all the problems should be reported by sending an email to support@company.com, right? Or using this portal, the ticket management system portal, where you go in and uh, put your the description of the problem, and then we will call you within certain time. Right? Also, who do you call if you have a problem in the network? Should you call the president of the company or the tech support? Right? So sometimes there are issues related, or the SLA describes escalation problem or escalation procedure. What is the escalation? So you may call the tech support, that's the first number that you call, the 1-800 number in North America. So you call and report your problem. If you don't get the proper support within the time, you may call the manager. If the manager does not respond or does not, or the problem is too big, you may call their, senior vice president or something. So this is the escalation process. You don't really start calling the vice president right away for a minor problem. So you this SLA describes the escalation process. Uh, Then we have a clause about the monitoring and reporting service level. So who monitors the service level? Who monitors the reliability? Who monitors the bandwidth? If we um, sometimes each part of the or both sides disagree on the percentage of the 99.5, the customer will say, no, 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 we didn't receive 99.5. The ISP says, no, we provided you with the 99.5 reliability. So who do we trust here? So usually the service level agreement sets or puts uh, the uh, the standard of the reporting. Usually, who reports the reliability is the service level, is the ISP. The ISP is the one that reports the reliability, and sometimes they provide um, a portal for the customer to go and see the information about them that's being managed by the ISP. So the customer can go to a portal provided by the ISP and see the traffic levels, and they see the reliability and other factors. So they can monitor the level or monitor their service from the customer, from the ISP point of view, right? The ISP may also agree to provide a report every month about their service. Well, we provided you with this service. This is how much money we we ask you to pay, and this is the parameters. So they provide you with the report. Same thing if a company is responsible. If you outsource the network management to another company, they will give you a report every month about what's happening in your network, right? And we talked about the consequences. Here, the escape clause is the last one we talk about. So the escape clause, in certain circumstances, it's impossible for the service provider to provide service. Let's say the internet service provider is facing outages because of hurricane or because of earthquake or because of any disaster, any environmental disaster or other kind of disasters. So is it reasonable for the customer to complain about not receiving a service? So that's why sometimes the SLA includes an escape clause that says uh, under extreme circumstances, this SLA is not valid, or we cannot adhere to the terms of this SLA, right? So that protects the service provider from being sued, for example, for not providing the service in during a major disaster or during maybe kind of civil disruption or any kind of a problem. You will see a brief description in your notes about the cloud challenges. So when you put your infrastructure in the cloud, you still need to maintain network management and monitoring. You do not delegate this task to the cloud provider. The cloud provider will give you resources, but everything else it's up to you. It may also give you some tools to monitor your network, but it's still up to you to maintain or keep an eye on your network, including we saw that in the security tasks also is your responsibility, right? So network management, the same thing. It's still your responsibility to maintain the management of your network, even if your network is virtual and it's located somewhere else, right? But it's still your responsibility. All right, the last thing we talk about in this recording is change management. We talked about change management early in the configuration management, and the reason behind change management is to make sure that any change happens efficiently and it doesn't cause any disruption to the normal work in the network and recover on and minimizes the risk to the business, right? So where does the description of change management comes? It comes from the ITIL. We talked about the functional areas, the five functional areas. We talked about them as part of the OSI framework. We talked about them also as part of the TMN framework. But the ITIL is the main source for all the change management procedures. In some companies, change management is big task and they have a dedicated department to it. But even if you are a single person managing a network, you still need to learn about change management and apply some of the concept of change management, right? For the reasons explained in these slides. So, for example, um, if you are creating VLANs on regular basis, you may be looking at standardizing the process of creating a VLAN. So to minimize the risk. So what I mean by that, maybe you create a script using Python or just write the configuration commands on a in a a file and just copy and paste. Copy and paste is the simplest form of automation that you can have, right? So um, why we do that? Well, when we do standardized methods, we minimize the risk. When you do a script that changes the VLAN, it removes a lot of potential mistakes with typing, for example. Right? That's a VLAN. Imagine if you are uh, upgrading the entire network. So the change from the VLAN change is very, very small, while upgrading the entire network is very big task. But both are considered change, right? So we'll see later there are levels of change. But the idea of change management is generally means that we need to minimize the risk. Somebody goes and pull a cable in the middle of the day, middle of working day from the network, that's a bad practice that may cost you a job because it may disrupt the network. So if you want to do a job in the network, you may find a good time to do it to minimize the risk to the business, right? Any change in the network should align with the business objectives. As we saw earlier in the course, network management should align with business objective in general. So what does that mean? It means that I'm not just going to make a change just so that because I like it, because I heard there's a fancy protocol out there or a fancy technology that I want to implement, and it costs a lot of money and it just increases the cost to the business without actual benefit. Right? Another reason to apply change management practices is to minimize. There is a risk for a change. Every time I change something, there is a risk, right? But to minimize the risk, I have to apply change management process. We will see later that part of the change management process is to create a plan, see that our people will look at the plan and approval. Maybe there are other people who are involved in the change will look at it as well, consider all aspects. So that will minimize any uh, significant impacts on the business. And we also want to make sure that the change always successful the first time. We don't want to make the change multiple times. We don't want to learn while we're making a change, learn what in a production network. So, oh, I want to configure BGP, but I'm not really good. But I will try. If it doesn't work the first time, I will try again. So that's not really good practice. So we need to not do that. We need to find a better process for doing the change without, trial and error. Okay, so I already gave you two examples of what we mean by a change. It could be as simple as creating a VLAN, or it could be building a new data center. So the spectrum is wide here. In general, what we mean by a service change or a change is any addition, modification, removal um, um, of supported service or component. So you hear here that there is a term supported service or service component, right? So if I remove something that's not authorized, that's not a service change. If I see somebody connected to the network illegally and I take it out, that's not part of this, right? So that's something that service change or change management apply to something that's already being authorized to use in the network, but then later I want to modify it, change it, or add it. Right? The change can happen proactively or reactively. Proactively, when I make the change after planning, I need to increase the number of products that a company sells, so I need to add more servers that accept user orders. To add more servers, I need to provide the network infrastructure for that. So that's planning. And the change will happen because I am trying to support the business, right? Reactively, I see that the router is being busy, the CPU load is increasing or the free memory is decreasing, so I need to do something before it fails. That's a reactive, right? It could be considered also a proactive when I know that, well, the switches have been around for 3, 4 years, and before they start failing due to fatigue, I'm gonna upgrade them proactively. So that could be also considered a proactive approach. So, reactive maybe sometimes as a response to resolving errors, or adapting to unforeseen changes. All my employees started to work from home because of the pandemic, so now I have to upgrade my internet connection. So that's sort of a trying to adapt to a change, right? Um, a change, as part of the definition, a change can involve any configuration item or element of the IT infrastructure. So when we talk about change, we're not always talking about network specific change. It could be adding an application. It could be installing a piece of software for network management system. That's a change as well, right? You may say, well, why do anybody cares? Well, you don't know. Sometimes you create or you add software for network management system, the software starts polling, it adds traffic to the network, it adds congestion. Some parts of the network won't be happy about it, they will fail, right? So everything that you need to change in the network has to follow the change procedure, right? So here we're going to talk about when we talk about the change process and the change model, we have roles, right? So we're going to talk about the roles before the change model for some reason. But what are the roles here? So um, ideally, for a network, for a large organization, the change uh, process involves multiple people. Each person will have a task or will have a role in this change. But sometimes in a small organization, the role could be just by between one or two people. It doesn't matter. So I'll explain the roles in detail or in general here. But then you could imagine that the role itself or one person can have multiple roles. So let's say you detected that you need to upgrade the firewall in your organization. So in that case, you are the change initiator. The change initiator is the person who thinks about or perceives the need for a change. It could be also you are the person who think that you need a new piece of software to manage the network. So you need to make a change. So ideally, this person will create a proposal for a change. We'll call it a request for a change. And the RFC here is not the IETF RFC request for comments. This is a request for a change. So be, be careful about the acronym. So the request for a change is just a simple proposal or sometimes not simple, sometimes it's for a big change, it will be detailed proposal that it will include the reason for the change, the details, what is the model of the firewall that I need to purchase, why, how much it costs, who are the vendors or the possible vendors, and these details. The change manager is the person who oversees all the changes. So for a network, for a small organization, it could be your boss, or it could be you if you are the IT manager or the network manager. For large organization, could be a department that has project managers and people who are dedicated to this task. But this person will be overseeing all the changes. Um, then we have the change advisory board. This is uh, the role of, or this is not an organization, but a committee that involves multiple people, and their task is to approve the change. So who are these people? It depends on the change, right? So every change may have its own change advisory board. There may be some change advisory board that it's dedicated to networking, so they're always doing approvals for network changes. So examples of people who may be involved include the technical people, the technicians themselves, the network people, the IT people, server administrators, because they may be affected by any network change. So the persons who are have technical background could be uh, if the change require moving, require construction, then you will have the contractors. This could be the general employees who are going to be affected by a change, so they may have a say in how the change should be conducted. So if you want to build a new data center or build a server room, you may have people who are employees from different departments sitting on this and say, well, if you make this, that will disrupt our business for a while, so you should be concerned about this, or well, you cannot make a change in the last week of the month because this is where we prepare our payroll payment in the accounting department. So they will provide input, and they will also look at the proposal and approve it or reject it. Imagine if we want to do something in the university, so some people may be involved. Examples of people who may be involved in the CAB are representation from the students, representation from the faculty, representation from staff. So they all get involved into looking into these changes. And finally, the last role is the implementation team. These are the actual people who will implement the change. So, as I said earlier, this could be the same person. You propose adding or replacing the firewall, and it will be the same person who you will be the same person who uh, installed this firewall, or you may hire somebody to do it. So in that case, you could be the same person who does the initiator and the implementation, or it could be two different people. Right? All right, so these are the roles. What are the models? The models represent the steps needed to implement the change. We talked about the changes, but we didn't talk about the steps, right? So the steps, the chronological order, the order of the steps, the responsibilities, who does what, all of this is part of the change model. Time scales, escalation procedures, approval authority, and monitor the quality of performance. So we could have probably talked about this slide before that we talked about the roles, because the roles are part of the change model here. But anyways, um, so when we talk about, let's talk about the process. So what is the process? Now you're thinking, uh, if I want to assign an IP address or I want to create a VLAN, should I go and do all of this and talk to managers and cab? And that seems to me like uh, probably just easier to change jobs or change careers. Well, again, changes are different in size, in scale, so we have different processes for that. So we have here 5 types of change processes: normal change, standard, emergency, minor, and major. And in some sources, we talk about only normal, standard, and emergency, right? But the references in your notes talk about 5. And again, if you want to learn more about change process and change management, you refer to the ITIL documentation. So let's go to the most elaborate of these, which is the normal change. It's called normal change, so that's the change that has all the steps, right? So any a change that's classified as normal change will go through the entire process. So what is the entire process? Well, first you create the request for a change. In some organizations, you have a system where you request the change and then supply it. I have a friend of mine who works for an organization and he manages databases. So every time they want to change, they have to go through a process. Right? Even a simple query has to go through a process because it is really they're taking change management very seriously. So you create the request and you log it in a system. In a simple organization, you may just create a proposal and send it by email to your boss, right, to your manager. So it doesn't have to be, but the process is the same anyways. Um, Somebody reviews the request for a change. This could be somebody else, another colleague. It could be the manager. It could be anyway some another pair of eyes that look at the process, look at the request. Then we'll get to the evaluation of the change and authorization of the change. These are happen by the cab. So the cab will look. The cab in general is the role that if authorize the change, and sometimes the evaluation can happen by another technical team or the cab itself or the manager. So anyway, we need evaluation. If the change is authorized, we need to implement it, and after the implementation, of course, the process will be closed. So the implementation will go back to the cab and they will say, okay, this did everything go well, what we learned from this. And in a case where the change cannot happen or there is a problem, we need to create a backup, or we need to create a back out plan. So we didn't I didn't go into much detail in this slide, but if you look at the procedure itself, it may be more elaborate than this. So in general, any change has to have a backout. So when you want to create a new VLAN, right? The simplest thing you need to do is to save the configuration of the switch before you make any change. If the worst thing happen, you can just reboot the switch. Or, well, rebooting a switch probably the last resort, but as long as you have a backup, something that you go back to when things go wrong. For example, when I upgrade a firewall, right? So replace a firewall, old firewall with a new firewall. I don't turn off the old firewall. I keep it running. Maybe disconnected, but keep it on, right? So if something happens to the new firewall, if my configuration has something wrong and it didn't work, I simply go back to the firewall. I didn't I don't turn it off until I'm making sure that my upgrade is successful. So this process is the that has all the steps, but sometimes these steps can be abbreviated or skipped if we have a simpler change. So we have two types of changes where we don't adhere to this process. One of them is called the standard or the pre-authorized change. So, for example, if you are tasked with adding a new employee to the network, so you need to give them a port on a switch or access to the wireless, and you need to record their MAC so that only them can connect to the network. So this process doesn't involve a lot of risk. It's not big task that will cause big trouble to the network. So you don't need to go and talk to the manager, get approval from the cab. You don't need to do all of this. So these are understood to be pre-authorized changes. If you do this task quite often and you have all the skills needed and everything is well documented and proven to be working, so you don't need the process, right? So it may be, it depends on your job. Sometimes if you are the manager of the IT of the network in a school, creating a VLAN doesn't happen very often. But if you are um, network administrator in a ca- uh, network service provider, you're probably creating VLANs every day, right, to accommodate different customers. So, from one perspective, adding a VLAN is a big task, and you need to tell people about it. And in the other example, VLANs happens all the time, so you may have a script that does it automatically for you. You don't need to go through all of that process. So we'll call these standard or pre-authorized changes. Another example of changes that does not require the formal process or the lengthy process is the emergency change. This is a switch fails, you need to replace it. You are subject to an attack, you need to um, counter the attack. So in that case, you need to make a change in a reactive mode, and it will be not reasonable to go and ask for permissions or write a report about the changes that you need to make. This is understood as an emergency, and at some point you need to go and provide the details. So if you are changing a routing in response to an emergency situation, you need to go back and document the change, right? So same way with the standard change, you need to document everything, even if after the fact. We have also two types of changes, minor and major. The minor change involves change when the risk is low but have some limited impact. So um, it may require some formal request for change, so you may start writing something, but the planning and approval may not involve a cab, may just need to be approved by the manager, the change manager, right? So what is the example? Well, it depends on the organization. Um, adding a VLAN or adding a subnet in your network may not be a big task that will require ask an advisory board to come and have a meeting, right? So it may be something that the change manager will be enough to look at it and say, okay, the risk is not big. You go ahead and change it. Right? Major change, on the other hand, uh, significant. Let's say the network or the company wants to move all of its network infrastructure, the servers, everything, applications, everything to the cloud. That's a major change for a lot of organizations and goes beyond the change management group. It may require financial analysis, it may require market study, it may require financial people, it may require risk assessment, and it may require approval from the CEO of the company or the senior management of the company. So this is not just something that a group of people that can decide the fate of the organization on their own. So it's not like the network manager say it's a good idea to move everything to the cloud. Let's do it and do this by the no. That's something that involves the higher hierarchy of the network, right? Because it has high impact, high risk to the organization, um, and it needs more careful thought, right? So you'll see here there are 5 different um, change processes. Each one of them has a specific definition, right? All right, so um, here's a question for you, but this brings us to the end of this recording and the end of chapter 4. Uh, chapter 4 talks about putting all the things that we learned in previous chapters in implementing a network management system. And this is now covers one of the major objectives of this course, learning outcomes of this course. So um, that's the end of this recording. Thank you, and I will see you in another recording.